Hello everyone, welcome to my channel. Today our topic is atomic structure. We will be talking about the representation of an element, about its subatomic particles, electronic configuration. So without further ado, let's quickly get into the video.
What is an atom? Atom is the basic particle in a chemical element. Any element has got a basic particle. That is what represented by an atom, or that is what we call as atom. Now this atom can be divided into subatomic particles. What are those? Proton, neutron and electron. Proton represented by P, neutron by N and electron by E. Now they have got some charge as well. Proton has got positive charge, neutron has neutral charge, it is chargeless basically, and electron is negatively charged. Okay, so an atom is divisible. From here we can basically state the fact that atom is divisible, which was previously said as the opposite, that atom is indivisible, but no, atom consists of subatomic particles, proton, neutron and electron. The structure of an atom. This is the basic structure of an atom. This circle inside is known as the nucleus of an atom. Okay, this nucleus consists of your proton and neutron, and in various shells, here only one shell is shown, we have got more shells like this, 1, 2, 3 and so on. It will continue from 1 till infinity, number of shells are present. In these shells what are present is your electrons. So basically our nucleus contain positive charge, because neutral plus positive gives you positive charge, and electrons or the shells give you negative charge. Okay, so shells are negatively charged. You can write this thing down, that protons and neutrons are present inside the nucleus and electrons are present in various shells surrounding the atom. You can also write this down, that extra nuclear part of an atom consists of subatomic particle, that is your electron, and the nucleus contains proton and neutron. Okay. How to find out the number of subatomic particle present in an atom? Now see, number of examples of atom you know: sodium, potassium, any element, calcium, hydrogen, lithium, beryllium, all these are atoms. Now in these cases I am telling you that there are subatomic particles. There are particles which can be divided, we can divide the atom and get those particles. But what are the values? If you get to know the basic representation of an element, then from there only we can find out the subatomic particles. An atom is represented by this symbol X with these two values provided. What are these two values? What does these represent? This value is your mass number. Mass number also stated as A, and this is your atomic number represented by Z. Mass number is nothing but the atomic weight. Whatever is the weight of that element, that is your mass number. And atomic number is the serial number or the value of the element in the periodic table. Simply remember, the roll number of an element is your atomic number. That's it. Okay. These value will be provided. If provided to you, you can easily find out the subatomic particles. How? Atomic number is equal to number of protons, which is also equal to number of electrons, and another subatomic particle left, that is your neutron. A minus Z, mass number minus atomic number, is your number of neutrons. That's it. Okay. So what are the things required? Mass number and atomic number are two essential things that is important for finding out the subatomic particles. Okay. So you can write this thing down, that atomic number is equal to number of protons and electrons in a neutral species. This term is important. If the atom is neutral with no charge, neutral means the charge of the element is neutral or zero, and the number of neutron is equal to the difference of mass number and atomic number. Now see, list of elements from 1 to 20 is provided to you. 1 till 20 atomic number is given. Now when these values are provided to you, it's easy now. You can find out the proton, neutron, electron easily. And this mass number, see, mass number you can also remember. If you can remember these values from 1 to 20, it's very easy to find out anything, any number of subatomic particle. Mass number is almost the double or double plus 2. See, 4 into 2 plus 1 is 9, 5 into 2 plus 1, 6 into 2, 7 into 2 and so on. Only in case of hydrogen, we have got only one atom, although the isotopes of hydrogen has got different values. Now, electronic configuration, we are talking about electrons, subatomic particles, but there is a particular factor or there is a particular rule of arranging these electrons. Protons and neutrons have got no arrangement, they will remain inside the nucleus of an atom just like that. But electrons have got shells. Consider the shells as rooms. Like if you are having 3 rooms in your house, which room is going to be provided to how many people? That is what is your question mark. So that value will be obtained in this method. Now we will be talking about electronic configuration. Okay. So electronic configuration is basically, consider like this. If you are provided with 4 rooms and you are total 12 people in number, who will be provided or how many people will be provided how many rooms? That is what is your electronic configuration all about. Your protons and neutrons need no room. They will be staying inside the nucleus as it is. Whatever be the number of protons, they will be inside the nucleus altogether. But the electrons have got more space. They are provided with more number of shells. Now, simply the arrangement of electrons in various shells of an atom is what is electronic configuration. So, we can arrange them in various shells. Now, how will we arrange them? That has got a formula. 2n square is the formula which is provided to get the maximum number of electrons present in each shell. Suppose one room, only 4 people can stay. Similarly, in the first room or the first shell which is having value 1, second shell having value 2 and so on, first shell will be having 2 electrons, 2 into 1 square, 2. Second room or second shell, 2 into 2 square, that is your 8. Third shell, 2 into 3 square, 18 and so on. This is how we can arrange the elements or the electrons in an atom. So, let us try to find out the electronic configuration. For that, first it is important to know the atomic number, because that is from where we will be getting the number of electrons. Sodium is 11. Please, you can refer the table I have provided over here. Okay. So, electron is also equal to 11. Correct? No problem. Now, first shell we found 2 electrons, second shell 8, third shell 18 and so on. Right. So, 2, 8, 1. This is the representation, because first shell can accommodate maximum 2 electrons, no more space. Now, next move to the next room, 8 electrons. Third room can accommodate 18, however, we are having only 1 electron. So, that is how representation is done. So, electronic configuration is arranging the electron. Next, potassium. Potassium has got value 18. Sorry, it is not 18, it is 19. First shell same 2, 8. Third shell, now you tell me, third shell can consider 18 electrons and you are left with 9 electrons. Can I write this? Is this correct? No, this is wrong. See, these values have got a significance. Why 2 electrons? Why 8 electrons? Basically, it has been found these value provides stability to the atom. 2 means duplet. Duplet rule provides this value which gives stability to the atom. 8 means octet and that gives stability. Again, 18 also gives a value amount of stability. However, if you are not having 18 electrons, you have to repeat the 8 series again. For example, either 8 or 18, nothing in between. So, you are having 9. Can I write 9? No. Then what is my new formula or new configuration? 2, 8, 8, 1. This is allowed because 8 is providing stability. Whoever provides no stability will not be allowed. So, 9 over here is discarded. You cannot write 9. So, this is correct. Next, you can write 18 only when you have 18 electrons. Something greater than 18 is allowed to be written. If you have 18 electron, you can write 18, then 1 or till 18. So, this is how we proceed. Helium is very easy. Helium is 2. So, the electronic configuration is also 2. So, this is how we can represent our electronic configuration. What do you mean by duplet and octet electronic configuration? Just now I said You can keep this thing written. When the number of electrons in the first shell is equivalent to 2, it is known as duplet. The word duplet is coming because of 2. So, only in first shell you are going to have 2 electrons. For example, in helium, it is the only atom with duplet configuration, or the only noble gas with duplet configuration. When the number of electrons in various shells is equal to 8, then it is known as your octet configuration, except in the first shell. In the first shell you cannot have 8 electrons, it is only 2. After that it keeps on increasing and the value increases to 8. So, octet rule or octet configuration is that, and these values are significant because they provide stability to an atom. Every single thing in the world needs stability, even an atom. So, these values, octet or 8, these values provide stability. The atom, when reaches this state, they are stable. So, this is what is your octet and duplet configuration.